Hello everybody, I hope you're doing well and welcome to the platform of CodeChef. Okay, so today we're going to be solving the problem minimum and maximum partition. The difficulty level for this problem is simple and the prerequisites required are your basic sortings. This is your educator Ansh and I hope you like my video. Let's proceed to the problem statement. Okay, now let us try and understand the problem statement. So minimum maximum partition. You are given a sequence of n integers. A. You need to partition the sequence where the cost of making a partition from L to R is nothing but a left element plus a right element. Output the minimum and maximum total cost of partitioning or making exactly k partitions where the total cost is the sum of costs of each partition. Okay, so let me just summarize what the question is saying. The question is saying that you need to partition the array, or basically you need to partition the sequence of n integers into k partitions. Whenever you partition the array, your cost of partitioning is nothing but the sum of starting element of the partition plus sum of the ending element of the partition. So let me demonstrate you what the problem statement exactly means using this example test case, right? So basically, here the question is saying I have integer of 5, or basically an array of 5 integers. My k is equals to 2. That means I have to partition the array into two partitions. So consider my array 1, 2, 3, 4, and 5. So if I partition the array this way, that means this particular thing is my one partition, and let's say this particular thing is my second partition. What is the cost of this particular array, right? The cost of this array will be nothing but the starting element of this particular partition, which is 1, plus ending element of this partition, which is again 1, the starting element of this partition, which is 2, plus ending element of this partition, which is 5, right? And the total cost is 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 5 is 9, right? And 9 is the minimum cost that we can obtain in this particular problem. And for the maximum partition, the problem is saying that we can partition it in such a way, right? So first I am given my 1, 2, 3, 4, 5. So let's partition the array in such a way. This is my partition. So here, the cost of this partition is nothing but 1 plus 4, the starting element plus ending element, and this partition is nothing but 5 plus 5, right? So this is what the problem is saying, because the starting element is itself and the ending element is the element itself. So yeah, your cost is 5 plus 5, 10, 14 and 15, and hence the answer for this case is 15, right? Because the sum is 15. So this is what the problem statement is asking. Okay, now let's see how we can approach this particular problem. So to decide our approach for that problem also, let us consider the example test case. So we have 5, 2, and we have 1, 2, 3, 4, 5, right? Now one thing is fairly obvious, that irrespective of whatever partitions we make, our answer will always include my first element as well as the last element, right? Because consider this situation, say these are my partitions. So irrespective in the answer, because of this partition, my first element will be included, and because of this partition, my last element will be included, right? So when there are no partitions, say my array is in this format, let me make a entire partition of the array denoting the array is comprising only of one partition. And here the first element and last element are included. So initially my answer is nothing but fixed, that it is 1 plus 5, which is 6, right, in only one partition. But then my partitioning is 2. Now how to determine where to partition to obtain my minimum or maximum answer? So for that the observation is simple. What we'll do is we'll take every two adjacent sums and store it somewhere. So basically we'll take sum of 1 plus 2, which is 3. We'll take sum of 2 plus 3, which is 5. We'll take sum of 3 plus 4, which is 7. We'll take sum of 4 plus 5, which is 9. Right? This is the way. Now, what we'll do is we'll sort this array. So, firstly, in this case, the array is always sorted, but we'll sort this particular array. Now, whenever we pick up any of this value, what we're indicating, so I know my answer is initially as 6 in one partition. Whenever I want to increase my partition, so say there are two partitions, I'll take another value from this particular answer. So basically, I'll take this value and my answer will become 6 plus 3 equals to 9, and it will denote by taking this value or by taking this value of any two adjacent sums. I'm saying that I am placing a partition between those adjacent sums, and the cost of placing this particular partition is nothing but this 3, right? So if we can see in this particular case, our initial answer was 6, which was fine. By using this sum or by placing this partition, I got another cost of 1 plus 2, which is 3, right? So my total sum became 6 plus 3, which equals to 9. So we can calculate it in the normal way also. Like consider this partition. Here the sum was 1 plus 1 and here the sum was 2 plus 5, which is equals to 5 plus 2 7 plus 2 9, right? So 9 is same as this sum. Again, say my k was 3, not 2 in this case, then we'll also consider this particular partition 5. That means we'll partition the array one more time and my 2 and 3 one time will also get included in our answer. So our answer will be nothing but 9 plus 5, which is 14. If my partitions were 3, and here you can calculate also. So here it's 1 plus 1, here it's 2 plus 2, 1 plus 1 is 2, 2 plus 2 is 4, so 2 plus 4 is 6. Here it is, after 6 it is 5 plus 3, which is 5 plus 3 is 8, and 8 plus 6 is 14. So as you can see, if we manually calculate, we'll get our answer. So the problem is simple. Once we initialize our answer as the sum of first and last element, we can generate sum of all the adjacent elements and we can keep it in the array. Now for my one partition, the answer is fixed. So for the rest k minus 1 partitions, what we can do is we can greedily select the smallest values from this particular partitions in order to get the minimum value. Whichever value we are selecting, that means we are creating a partitioning between those two adjacent elements, right? That is the approach. In order to do the and in order to find the maximum, we'll do the reverse. Like in this particular array, we'll start traversing from the behind values because those are the maximum, right? Because we sorted the array. And yeah, travel for the so basically for k is equals to 2, I'll search for the last value. For k is equals to 3, I'll search for the last and the second last value. And this will give me the required answer for the following problem. This is the approach of this problem. Now let us move on to the coding section to understand this approach perfectly. Okay, now let us try and understand what a code for the following problem. So here I included all my header files and the necessary constants. Then in my main function, I simply called my solve function because there's only one test case in this particular problem, right? In my solve function, I took input n and k according to the input format. I initialized my vector of length n and another initialized the vector of v. Right? Then I took input for the array in a vector of n length according to the input format. Now as we discussed in the approach section, our minimum cost and maximum cost was initially nothing but my sum of the first element and the sum of the last element. So I initially initialized both of them as the following sum. Then in my approach section as we discussed, we'll make an array of every adjacent element. So I made an array of adjacent elements and appended them in my V array. Then I sorted my array. Then our approach was simple that I included one element here. So for the next k minus 1th value or for next k minus 1 partitions, what we can do is we can just greedily select the top smallest values for the minimum cost. So basically for k minus 1 values, I incremented those values in my minimum cost, denoting that I'll partition it over those elements. And for maximum cost, it is nothing but we'll select the last k minus 1 values. That is the idea. So we selected the last k minus 1 values for the maximum cost and we outputted our minimum and maximum cost. So now let us run our code on example test cases to see whether everything works correctly or not. So as you can see, we got the exact answer according to the expected output. Now let us submit our code on the actual test cases to understand whether it works correctly or not. Okay, so as you can see, we got the correct answer for the following problem, and yes, this becomes a valid approach to solve this particular problem. Okay, now let us discuss what mistakes people can make in this particular problem. So here the key part was nothing but taking the observation was very important of taking the adjacent element sum, sorting it and getting the first k and the last k values for the maximum and minimum sum. So if that particular observation was clear, I don't think anywhere else the code is very complicated. As you can see, it is quite simple to implement. So if those observation was clear, there are less chances of making mistakes in the implementation of part of the code. And yes, so I don't think there's any chances of making mistakes in those parts, right? This is the learning you get from watching my video. I hope you like this video. Please like, share and subscribe to my channel. Thank you.